Creating these classes requires equipment and services that cost money. If you appreciate this education, please think about going to elithecomputerguy.com and offering a one-time or monthly recurring donation. Welcome back. So in today's video, I'm going to do an introduction to databases in regards to cloud computing. Now, I do have to warn you, if you are an expert in databases, turn back now, leave. Go away. Watch Game of Thrones. The way that I'm going to probably do this introduction today is most likely going to piss off a lot of old school database administrators, because the problem that I have is when I am talking to people, I am talking to new people, and so I have to find some place to start in order to give folks context for everything else that I talk about later. And so one of the issues you run into when you're doing introductory classes is you frustrate a lot of the old timers because they're like, oh, that's not how it is, Eli. And you're like, well, yeah, in the real world it gets a lot more complex, and there's a lot of stuff in the real world, but I have to find some place to start from. And so I am going to be starting by talking about relational databases. I think this is a good place to start when we start talking about databases, especially in the cloud computing world, because relational databases are most likely the types of databases that you will have run into in your normal day-to-day work, and the type of databases that are most likely easiest for you to spin up. So there are different types of databases out there. They focus on being able to deal with data in different ways. Basically, relational databases is just one way that's been around for quite a long time now. And if you're going to be dealing with databases such as MySQL databases or MariaDB, a lot of the different types of databases out there, basically they are going to be relational databases. So if you are a database expert, let me be clear. Yeah, I know, I'm glossing over a lot of crap. It's an introductory class. Cut me a break here. Right, so when we start talking about databases, the important thing to be realizing when you're talking about databases is all a database does, or all database software or a service does, is it stores data in a way that is very easy, basically, to search for and to be able to modify. So that's all a database server does. So this is very important because a lot of times when people start interacting with databases for the first time, they'll use a piece of software such as Access. So Access is a piece of database software that Microsoft creates, and the way that Microsoft does everything, which is good from a production standpoint, but is horrible from an education standpoint, is they kind of bundle everything together. So when you're dealing with Access databases, basically Access has the database component, and it has the front end component, and it has the intelligence. Basically, when you deal with Access, you're dealing with a full product, right? So one of the problems is when people go out to start using, let's say, MS SQL or MySQL or MariaDB or some of this other database software, they get really confused because they're like, okay, I installed the database software. Where do I find the front end? Where do I find the intelligence? And it's like, no. All a database does is it stores the data. You then have to use some other front end, and you have to code the intelligence or have the intelligence coded for you to make that database actually do something worthwhile, right? So when you're dealing with a database, most likely, again, if you're going to be using relational databases, MySQL, MS SQL, something like that, in order to interact with the database, you will be using something called SQL, or Structured Query Language. And basically what that structured query language allows you to do is it allows you to do things like create databases, create tables, create records, search through databases for records within tables. It allows you to do modifications, a whole bunch of things. But it's very command line. It's very command. Select, X, where, blah, at, right? It's kind of like, again, it would be kind of like trying to surf through the World Wide Web at the command line. There are tools, I think there's something called Links, that allows you to actually navigate the World Wide Web from the command line. But nobody other than really hardcore Linux administrators would actually ever even think about doing something like that. It's just a horrible process, right? And so that's one thing to realize with the databases, again, MySQL or whatever, right, MariaDB, whatever database you're going to use, is you have the database software. You're able to interact with the database software using something called structured query language or whatever language that they use. But that is horrible and nasty and god-awful, and it's not actually how any normal person is going to be interacting with the database. How people actually are going to be interacting with the database is there is going to be some front end that has been developed. So basically the front end is either like a website that you go to or some kind of application that's been created for your Windows or your iPhone or whatever else. Then there will be intelligence. So basically you have the front end, and then you code for that front end to be able to communicate with your database. So such as like if you're dealing with something like WordPress or Drupal, basically you have a front end, and that front end is HTML and CSS and that type of thing. You have a MySQL backend, and then you use PHP. So basically when you insert data, so when you create a user account or when you create a post or something like that, basically PHP takes that information, and then with PHP, that information is then inputted into the database. When you go to read a post off of something like WordPress and you click the link, what happens there is PHP goes, finds the records associated with that post. It then pulls that out of the database, depending on the formatting, it then formats it so that you can then read it, and so then you're reading it. So one of the important things to remember when you're dealing with databases is all the database does is it just stores the data. Basically, it stores those records so that you can access them. How you actually access them, though, is generally through some external application, and then there's some programming language that communicates from that application back to the database. It's kind of, think about like a file server. Imagine if you had a file server and you had a whole bunch of documents, Excel spreadsheets and documents and PDF files or whatever else on that file server. Now imagine you have the file server, but you don't have Word, and you don't have Excel or anything that can open up a spreadsheet. You don't have any of that kind of software, right? That's the same kind of thing. Imagine just a file server. Just a file server. It doesn't have Adobe Acrobat installed. It doesn't have Word or OpenOffice or anything installed. All it does is store files. So the files are there, the data is there, but in order to be able to actually access that data and do anything useful for it, you need an application installed on your computer that is able to read that data type, and then you're able to communicate with it over the network, and then you're able to open it and modify it. Kind of think about that like with databases. So basically, you have this database software installed on your server, but to really do anything useful with that database, you need some kind of external application that's been created. That external application will then be communicating with the database to push and pull and do whatever intelligence that database requires. So that kind of gives you a little bit of a brief idea of what we're talking about with the databases, to kind of get you in the right mindset here. So now that you have a brief idea of what a database is, let's go over to the whiteboard so I can draw some things out to try to give you a visual representation of what's going on. So I think it'll make a little bit more sense for you. So let's kind of draw this out. Let's do a little bit of a diagram of how this whole database system works and how clients are going to be interacting with it. Now, the important thing to be thinking about when I start talking about, the database is that the modern world of databases has become much more complicated than how it used to be. So I am trying to give you a basis here so that when you start reading and learning more about databases going into the future, you have a base idea of what's supposed to be going on, and then you can understand what functions or features the product that you're looking at offers. So basically in the old days, we had a server. We had the server with the good old CPU fan on it, right? So you have the physical server, you have an OS installed on the server, and then on top of that OS, you have a database such as MySQL installed. So basically you're going to have to actually install the database software. So whether it's MySQL, whether it's Maria MariaDB, whether it's some type of Oracle product, MongoDB. There's a lot of different databases out there. But again, the general that you'll be using is MySQL. And the important thing to understand is you actually have to install that onto the server operating system that you're using. Then, once you have MySQL actually installed on your system, within MySQL, the first unit you're going to deal with is a database, right? So the database is the highest unit that you're going to be dealing with within a database server. So you can have a database. So like a lot of times with databases, so if you're having WordPress websites, so WordPress websites connect back to a MySQL backend. So when we talk about a backend, we're normally talking about a database server. So it communicates with a MySQL backend. So for like me, I have EliTheComputerGuy.com, right? So EliTheComputerGuy.com uses WordPress. And so for EliTheComputerGuy.com, there is a specific database for the information for EliTheComputerGuy.com. On the same server, I have a website called FailNormal.com. And it has its own database. So the database is kind of like the root, right? That it's the highest level that we're going to be dealing with when we're dealing with a database server. Then from there, basically you have software that's been encoded to be able to push and pull data to that particular database. So if you go to EliTheComputerGuy.com, right, you go to the website EliTheComputerGuy.com, and you see all kinds of fancy stuff there. Basically what's happening, right, so I have my web server. My web server has PHP installed, and so the PHP programming language is communicating with the EliTheComputerGuy.com database, and it's basically pushing and pulling data from that database. So when I sit down and I write a post, and then I click the little publish button, that then sends everything that I've written for that post to the database on the database server, and then that's written there. Then if somebody wants to read the post, they open the post up. Basically, the PHP goes to the database on the database server, says, hey, I need the record for this particular post, and then that is sent. That gets encoded with HTML and CSS, and then I am able to view whatever is going on here. So that kind of gives you the idea of what's happening. Now, it is important to understand that you can communicate between multiple databases, right? So again, since we're going to be interacting with databases, basically with a programming language, the reality is we can connect to multiple databases. So let's say there's one database server here and one database server here. So again, so something like if you're trying to create some application that allows your users to buy products from something like Amazon.com. So you have your user, let's say .com database server, and so you have a user database here, and then you want to connect to Amazon.com for whatever products that they're offering, right? So basically, you want to create an app that connects users and recommends products. Well, since you can code everything out in PHP or Python or whatever programming language, one of the things that you can do is you can have your software, your application that you've created, it can communicate with your user database. It can pull out usernames and preferences and shipping addresses and all kinds of stuff, right? And it can also go to Amazon.com's database and pull out, products and prices and maybe reviews and other things. And basically it's able to pull all of that information together so that when one of your users goes to a website, they get the recommendations that are most appropriate to them. So it is important to understand when we talk about these database files, they are the highest level of storage within a database server, but you can communicate with different database files, basically based off of how you encode your software, right? So you're going to be sitting there, you're going to be writing your application in PHP, Python, or whatever else, and then you can have that application be able to connect to these multiple different databases. So that's an important thing. Like a lot of people get confused. They try to dump way too much crap into a single database because there's this kind of this idea like, oh, the database is the largest, like that's the largest unit I can have. So therefore, I'm just going to keep dumping so much crap into that database. and then you get into a problem where it becomes just a mess to try to manage that database because it's containing way too much crap. And so something to be thinking about is, no, you can have one database that focuses on one specific thing for your company or your organization. And then you can have another database that focuses on a different thing. And if those two need to communicate, all you do is in a programming language, you write a script that communicates with both databases and then pulls the information in that it needs. So that's one of the important things to realize when you're dealing with the databases. So then, past that, so we're going to have our server, right? We're going to have, MySQL, MariaDB, whatever else installed, and then we're going to have our database. So the database is the largest, again, the largest unit that you're going to be dealing with within a database server, right? So let's say we have EliTheComputerGuy.com. This is the database within MySQL. And so within here, under the database, you're then going to be dealing with something called tables. So tables are basically containers for the same type of information. So let's say you have a table for users. And then you have a table, again, if we're dealing with something like WordPress, we're dealing with a blog system, then we have a table for posts. And then we may have another table for pages, right? So basically, once you have that large database, so the database itself contains all the data for EliTheComputerGuy.com. And then within there, you have tables, and those tables are basically compartmentalized specific information. So you have a user table, a post table, a pages table. And again, if you go in and you actually look at a WordPress.com or WordPress database, I think it's like 20 or 30 different tables of different types of information that have to be stored, but they store them in different tables to make it easier to be able to administer and manage. Again, that's one of the big things to be thinking about as a real IT professional, is trying to compartmentalize content and things into rational units. So basically somebody can go, oh, I need to see what the user information is, and I can simply go to the user table within the EliTheComputerGuy.com database. Imagine if everything was just stored in one massive table. That could run you into some problems, right? So then once you get past the table, then you have columns in the table, right? So again, if you're dealing with a user table, you may then have the user ID. So basically you need one ID number. So you need an ID number that is completely unique in a table, right? So basically to make sure that no records are absolutely identical. Again, one of the problems you run into in the real world of IT is computers can't think on their feet. Computers can't just invent new ways of doing things, right? So if you have two records that are actually absolutely identical, that can run into a big problem for the database. Because imagine if you're doing a search in a table and you're looking for something. I need the one record that looks like this. What if you have multiple records that are literally identical? Right? You can actually run into problems from the computer realm. Now you may sit there and you may say, well, wait a minute, but what if I do a search and I do that search and my results look identical? Well, the thing is, the first name may be identical, the last name may be identical, the notes may be identical, but the user ID, the unique key, it's called a key, the unique key will be different, right? So basically, if you're looking at records, so let's say you use PHP and you're doing a report. So you do PHP and you're doing a report. You say, I want this information, this information, this information. Well, you may get, Bob, Billy, and is age 12, and you may get Bob, Billy is age 12, and you may get Bob, Billy is age 12. And so you say, well, wait a minute, Eli, these records are identical. When I asked for this information, I got 3 identical Bob, Billy, age 12s. But what may not be printing out on that report that you're looking at is that there's a customer ID field. And so this Bob Billy, age 12, may be record 101. And this Bob Billy, age 12, may be record 1001. And this Bob Billy, age 12, may be record, 55. And so I know, like right now, that may not seem You may be like, well, I don't understand why that matters. But the important thing is when you're doing searches, when you're trying to modify records, when you're doing that type of thing, you need some kind of unique ID for the records that you're dealing with, or things are going to get really, really bad really, really fast, right? And so when you're dealing with a table, the first thing that you'll have in your table is some kind of unique key. It's called a key. You need a unique key within the table so that every record is different. Like they're not completely identical. If you have an identical record, your database will go to hell really damn quick. Then past that, then you have something like the first name, then you have the last name, then again, if it's users, maybe you have passwords, so on and so forth. And so these right here are called the columns. So these are the columns. And so when you're looking at the database, what will be going across the top, again, normally, it will be, like I say, you'll have some kind of user ID, you'll have like a first name, last name, so on and so forth. Then going across this is what we call the rows. And so the rows are then the records themselves. So we have a user ID of 1, a first name of Bob, a last name, a last name of Billy, so on and so forth. User ID 2, and this is Sue, Stevens, so on and so forth. User ID 3, and so this is where the records are, and so that's how you'll then store the records. So when you start looking at the database, again, you have a server. So you have a server somewhere. That server has the server software installed on it, MySQL, MariaDB, MongoDB, whatever else. Within that server is then a database. So you have the whole database. So that's the highest level that's going to contain the data. Within that database, you then have tables. Those tables are then basically ways to section off and be able to basically be able to categorize the type of information that you're going to be dealing with for that table. So again, you can have a users table, a post table, a pages table, that type of thing. And then in there, the up and down, those are the columns. So the columns are basically the fields. Again, when you think about plugging something in, fields. So again, the fields, you'll have a user ID, so you will have a unique key. You have to have at least one unique key. So that every record actually is individual. None of them are actually exactly the same. Then past that, for the fields, for the columns, again, first name, last name, whatever information that you care about. Once you have that, then you can start inserting records into that table. And so that's where you have user ID 1 is Bob, Billy. User ID 2 is Sue, Stevens. User ID 3 is Tim, Bob's, right? And so on and so forth. And so that's basically what the database starts looking like. So now we get into, when I talk about a relational database, what do I mean by a relational database? So let me scroll down here. So let's start with the overall database. So again, we have the overall database here, and let's say talk about an inventory database or a sales database, let's say. And so we're going to have multiple different tables here. So we're going to have a customer table, then let's say we're going to have a parts table, and then we're going to have an order table, right? So we're going to have these 3 different tables. So then if we go and we take a look at, let's say, the customer table, we're going to have a table for the customer, right? And so in the customer table, again, up here for the columns, we'll have a customer ID, then we'll have, let's say, a first name, and then we'll have a last name, and then we'll have notes, right? So this is the different information here. And so in this, then we have the rows. So these are the records. We have customer ID 1, 2, 3, 4, first name Sue, last name Bill, notes. First name Tim, last name Stevens, notes. Customer 3 is Bob, last name Billy, and then there's notes. And then customer 4 is, Ralph, Tim's, I'm bad with coming up with names, notes, right? So this is the customer table, right? And so the customer table, you have the customer ID, first name, last name, notes. And again, for this table, you could have a whole bunch of information here. You could have the street address, you could have the state, you have a tax ID number, lots and lots and lots and lots of things. Do realize when you're dealing with a table, it's not really that you're worried about the table size. It's not really that you're worried about how many fields the table contains. The real thing when you're dealing with a table is that it makes a logical sense, right? When somebody sits down and they're like, oh, I have to modify the database, they can sit there and they can easily say, okay, the information that we're going to start needing from the customers, for the customers, we're going to need this extra information. So that means I'm going to go and modify the customer table, right? That's the important thing. So this table here can be really, really, really large. And then past that, right, we have the parts table for this particular database. And so let's say with the parts table, right, you have the parts table. And so the parts table, again, you have the fields again, and then you're going to have a part ID, right? So the part ID is going to be an absolutely unique ID. It's going to be an absolutely unique key. And then from that, you're going to have the name for the part. And from that, you're going to have the price for the part. And let's say from that, you're going to have the description of the part. Right? And of course, lots and lots of stuff here, right? And so then basically here, these are your rows. These are what are called your records. So part ID 1 is a cog that costs $1. Part ID number 2 is a sprocket that costs $2. Part ID 3 is a wrench that costs $4, and part ID 4 is a lever that costs $2.50, just to make my life complicated. And then we're going to have a description over here, and these are going to be all the notes and all that kind of thing, right? So right here, so we have a customer table and we have a parts table. The big thing to realize is that there's this customer ID here and that there's this part ID here. And so what's going to then happen is you're going to have an order table, right? So you're going to have an order table. And so what's cool with the order table is you can come here and basically you can create the order table. So the order table is created. And so when you're dealing with the columns of the order table, the first thing that you're going to do is you're going to create an order ID. Again, you need a unique identifier for every single record that you're going to be creating. But when somebody goes to create an order, one of the things that you can then do is instead of plugging all of this information in to the order table, you can simply reference a particular ID. So what you can say is if you're saying that Sue Bill ordered something, what you can do is you can say customer ID 1, right? So here you have customer ID. And so when you have a record, right, you have order ID 1, customer ID 1. And so customer ID 1 references Sue, Bill, all of her information. So instead of having to put all of this information into the order table, you can simply reference that customer ID. And then when you go for the actual order itself, you can say, let's say item 1, item 2, item 3, so on and so forth. There's a better way of doing this. Again, do not design any application off of what I'm showing you today. I'm just trying to give you an idea of how this works. And so basically you can say, okay, with this order, the first thing that Sue ordered was a 3. The second thing Sue ordered was a 4. And the third thing that Sue ordered was a 2. Right? And so basically what this is saying is this for this order, so for order number 1, customer Sue purchased a wrench, a lever, and a sprocket. Right? So all of that information is there. And then you can have additional information like, this gets a little long, but again, let's say you have this, let's say you have the order table, right? The order table. So you have the order ID, the customer ID, item 1, item 2, item 3, right? So as we had before. And then here, you can then add in some of the additional things, right? So you could have notes. So additional notes. So for this order, so for order 1, Sue is purchasing, a 3, a 4, and a 2. And she may say, leave at back door. And so this way, we're creating an order that's able to pull in information from these other tables, and you're able to put in your own information for this particular table, right? And so what happens is you're going to use something like PHP, And so in order to do a report, so you're going to basically print a report. So printing, you do something like printing a report basically for the invoice, right? So you're going to do an invoice. And so what the invoice can do is with PHP can pull, it can pull from this order table, and then it will spell everything out. So it'll then say Sue Bill at the address, whatever address it is, ordered a 3, a 4, and a 2. I'm making this too complicated. Let's say a wrench, a lever, and a sprocket. And so then it can say, you know, wrench, lever, sprocket. And then it can say the wrench lever. So it's $2.50, $4, and 2. So then it can say, you know, $2.50, $4, and 2. And then it can do a little total. So with PHP can add these up. And so then that'll come to a total price of, you know, $8.50. And then at the bottom, there can be notes. And the notes will say, you know, deliver to back door, right? And so PHP will then print this out on your website, or it will print it out to the printer, so on and so forth. So what we're talking about with relational databases is basically, when we're talking about relational databases, you're talking about having different tables in the database and their kind of relation to each other, right? So again, you can have, let's say, if you have a part, so you can have a part, and then you can have a manufacturer table, and then you can have like an order table. And so these will have their own unique keys. And then those, so basically here, you would have the part ID as part of this table for orders. And then the part ID, part of this, would have a manufacturer ID that would relate to the manufacturer table. And so that's how the relational databases work. So basically, if I'm looking at the part and I want to do a report on the part, it'll give me all the information about the part. And then for the manufacturer, then we'll say what the ID for the manufacturer is. And for that, then it goes to the manufacturer table, and then it's able to pull out the information that's there. So that's what we're talking about with these relational databases. Now, one of the big things with relational databases that can kind of muck you up at the end of the day is what is called the schema. So basically, a lot of what I have just shown you is what the schema is. And so what the schema is when you develop the database, you are going to be doing all of the tables, and you are going to be plugging in all of the fields for information. So again, when we're dealing with a table here, right, you know, you have the user ID, you have the first name, you have the last name, you have, you know, notes or whatever else, right? And so basically right here, this is the schema. Why this can become a problem is many times in the real world of IT departments is you have a database administrator, so you have the person that's responsible for the MySQL database or the Oracle database, and then you have the coders. Oops. There we go. Come on. Then you have the coders. So PHP or Ruby or Python or whatever else. And then you have the users. Well, sometimes what will happen is the users will go to the developers, basically the coders, and they'll say, hey, you know how we have this nice form and it asks for a first name, a last name, notes, and that type of thing? Well, what we also want to do is we also want to have, let's say, a rewards number. So when you code all of this, we want to be able to create a rewards number and have that stored. Well, the problem is the people that are developing the PHP or the Ruby code, they may not have access to the schema, basically be able to modify the schema of the database. So if you come up with a rewards ID, right, but you have no rewards ID field in your database, then you're not going to have anywhere to store it. So one of the things that comes up is with the schemas, you really have to design the schema for everything that you think your application is going to require as far as data. You build this out, then this is more or less set in stone. And then from that, you write the software on top of that. So this is one of the things that can be a little bit complicated, is basically having the coders and having the database people make sure that they're on the same page with something called the schema. So that's the database server itself. That's the tables, that's the columns, that's the records. Now, one of the things that we have to look at is kind of the infrastructure that can be built when you're going to be dealing with database servers. So again, in the old days, and then the old way of thinking about it, when you're dealing with a database, you're going to have to deal with a database server too, right? So you're going to have a physical machine. That physical machine is going to have an OS installed on it. On top of that, you're going to have MySQL or MariaDB or MongoDB installed on top of that. And then within that, you're going to have all of your databases, and then your applications are going to be able to communicate with it. But you are going to be dealing with a server. And again, the old school way of dealing with this is you have a server. And so if you have a server, then you have to start thinking about things like, what is the best way for your users to be able to access data off of the servers? What about reliability? What about resiliency? If a hurricane comes through and literally wipes away all of your servers, then what do you do next? And so that's when you start getting into things like database server clustering, and then you start thinking about how you want the database servers to operate. Do you want them to be what are called read-write servers, read servers, or write servers? So the first thing when we start talking about the database servers and an overall infrastructure is, again, clusters, right? So when we talk about clusters, the idea here is that you have multiple servers that are able to communicate with each other, and they're basically able to replicate their data back and forth, right? And so that's one of the things you deal with when you're dealing with database servers is you deal with what are called replication strategies. And the idea is that if somebody adds data to one of the databases in a database server, that data is then replicated to the other servers in the cluster, so that if one of the servers fails, everything's okay because one of the other database servers in the cluster actually has the information. Now, one of the things you may be sitting there, you may be thinking about it, you may be like, well, okay, so if you have all these servers in a cluster, and so you're able to read from them and you're able to write to them, you know, that's great. You have a cluster for reliability. If any one fails, you're okay. But isn't that a hacking concern? If the more and more servers you have in a cluster, that's more and more servers that are vulnerable to an operating system attack, or maybe one of the systems doesn't get patched, or God knows what happens, right? If you can actually write to the databases on all of these servers, that is a possible vulnerability for hacking. And so that's when you start designing, and basically you start figuring out which ones of your servers will be able to have read-write. So basically read-write means if you go to that particular server, you can read from it and you can write to it. Then you can have other servers that are read-only, right? So let's say you're going to put a server out in the field. So you want a database server close to your employees. Let's say you have remote offices. So you want a database server that's close to your employees so that they can search for information, they can look up information, they can get information from the server, but you're worried about that hacking attack. So basically what you do is you make it read-only. So when they're sitting at their computer, they ask for data, they only get data back. Basically, that read server is only able to be read from. And then you can have other servers where, again, you're sitting there and you're thinking about, well, again, we're going to be building out an infrastructure. We're going to have a lot of write transactions to these servers, right? So let's say, think about like credit card databases or some kind of payment databases where you're just hammering the hell out of these database servers. You can actually make them write only. So these servers are literally only built in order to have information go into them. Once the information goes into them and they're able to process it, they then replicate that information, their databases, out to the read, write, and the read servers. So this is something to be thinking about when you start thinking about your actual server infrastructure. So again, let's say you have a main facility, right? And this has your MySQL databases in it. And so in here, you may have a cluster of database servers, and those are all read-write. So basically they're read and they're write. So basically people in the building will be able to read to them and they'll be able to write to them. These are fully functional servers. But then let's say, again, you have remote offices. So you have remote offices out here, and you want to put a MySQL database server in those remote offices so that when the users or the employees in that remote office need to be able to access data, they are able to access from the local server. So if the internet connection gets cut or any of the other stupid things that happen normally in the course of business, they are still able to read from the database, because you don't want a read-write database out in the field where any little hacker can simply walk in the door, plug in a piece of equipment to that particular server, and start putting data in that will get replicated back to your main servers. You don't want that kind of vulnerability, but you do want them to have read access. So that's where you would have something like the read server. Then imagine, again, you have something up in the cloud. Right, so basically, again, let's say you're having some kind of transaction server. So you spin up a MySQL instance. So you spin up a MySQL instance, you put it on a dedicated server in the cloud, and let's say you have all these users, and they're all doing, transactions. And so when they're doing transactions, they need to be able to write to a MySQL server. And so all that's going to be doing is writing. So that'll get written to, and then once the information is written, it then will then get replicated back down to the cluster that you have in your particular building. Now, how all of this is going to work, because you're sitting there going, oh my God, that's complicated. Well, that's where programming languages come in, right? So basically with the programming language, what you can have happen is basically when you're writing out your script, you can say, like when somebody goes to the website, pull data basically from local server. So you can set it up so it'll say pull data from local server, and then write data back to home server. So you can actually have it set up so when you have a user at your remote office and they pull up a web page, when they go to look up information, when you're getting a report, it simply is pulled from that local server. But when they go to write to the database, you can actually have it go so it'll actually route the data back to your main cluster sitting in your building, so that people aren't actually writing to the local server. And so again, this is where you start talking about like building out that intelligence and building out how the program will actually interact with all of these databases. And it can start to get pretty interesting here. But one of the big ideas is, again, when you start dealing with actual database infrastructure, you're going to have read-write databases, you're going to have write databases, you're going to have read databases. You set these databases up based off of their expected usage by the end user. So again, let's say you have a website that people are only going to read from. God bless you. Let's imagine you have a website where you totally got rid of the comments section. There is no comments. We don't want to hear your comments. We don't want to hear your comments, right? So you have a website, and when people go to the website, all that happens is their browser, basically you get a web page printed out based off of the information that the server is providing. So with that, you could literally have just a read-only database. You could have a read-only database because when PHP goes to the database, it will grab the information, it will then print to your screen, and you don't get to comment. You don't get to log in. You don't get to do anything else. None for you. We're tired of your crap. I don't want to hear what you have to say. Right? And so what you could do is, like with that kind of infrastructure, is again, in your building, you have a bunch of writers. And so what you could do is you could have a database server inside your building. Your writers are able to write to that database server. So when they write a post, right? When they write an article, that will get written to that server. And then you have a MySQL or a database server up in the cloud, and basically once they write to your local server, it will simply then replicate out to that read server. Why this is important then is basically you can lock down this communication. The only communication that can happen from the server on the cloud and your server locally is basically you can send outgoing replication data to the server. That's it. You shut down the ports. There's no SSH. There's no FTP. You only allow communication in the direction that you want. You only allow the ports that you require. And then that creates a nice point of security. So when users then go to access your website, they are then simply hitting a read-only database server that has basically no real connection back to your internal infrastructure. So this is a big problem that a lot of companies have, is they set up one of these MySQL or these database servers, they give it read, write access, and it's in the same effing building, it's the same facility, it's on the same subnet or network as everything else. And so you have a malicious actor is able to do something called a SQL injection attack. They're then able to gain control of that SQL server. And then once they've gained control of the SQL server, all hell breaks loose. If you have a read-only server that's sitting up in the cloud, the only way it gets communicated to by your internal infrastructure is simply by outgoing, basically, database updates. Then there is no write. There is no write here. You can't do the SQL injection attacks. Even if you could theoretically compromise this server, it's up on the cloud, it's firewalled to high hell and back, only the appropriate ports are open. So worst case scenario, you have to rebuild this one server versus worrying about your internal structure being compromised. So this is the type of thing that you really need to be thinking about when you start building out your database infrastructure. And this is one of those things that gets overlooked way too often. So that's a bit of an introduction to databases in regards to cloud computing for you. Again, if you're an old school database administrator, stop, just stop. I've got to start the kids somewhere. If you're a kid and you've been reading ahead in the book and you've heard about NoSQL databases and schema-less stuff and all that kind of stuff, just stop, come back. We will talk about all of that later. Again, one of the big problems we run into when we start talking about technology is all of these technologies are absolutely huge fields unto themselves. And so one of the issues you run into is where the hell do you start from? So I think by starting with relational databases, kind of talking about the old, how the old database servers worked, talking about, again, the databases themselves, talking about the tables, the columns, the records, talking a little bit about read, write, those types of servers and the clustering. I think this is a good place to start from, and then you can go out and you can start understanding a little bit more what you're looking at when you do start to research databases. Again, databases is huge. It's one of those things like it's just people overlook it. Like you don't realize, like being a database administrator for one particular product, that's a job. That's a job. For some reason, I don't know why it is. People just kind of overlook databases and they're just like, yeah, that little back end thing. But in reality, again, when you start talking about multiple servers, when you talk about millions or billions of records, when you talk about all these things, things get complicated very quick. And again, it requires a lot of maintenance. It requires a lot of understanding. One of the big things to be thinking about, though, when you're dealing with databases, again, when you're new, is do you realize all the database does is it stores the records, first names, last names, part numbers, that type of thing. That's it. Right? You don't get a front end with it. You don't get intelligence with it. You don't get all that fancy stuff. Again, when you sit down and you deal with Access and you're like, oh, this is database software? This isn't too bad. Just realize Access is giving you everything. Access is giving you the back end, the database component, and it's giving you the front end, basically able to build the user interface, and it's giving you the coding for the user interface to talk with the database. It's giving all of you that stuff in one package. When you go out, you use MySQL, MongoDB, MariaDB, Aurora, any of the 1,000 different databases out there. The important thing to understand is they're just going to give you the database. Here's where you store the records. Here's the tables, or you have to create your own tables, you have to create your own columns, you have to create your own records, and then you have to decide how you're going to communicate with that database. Is it going to be with Python, or PHP, or Java, or, God knows, C#? I don't know, it's up to you. What languages can communicate with that particular database? What is your particular situation? So on and so forth. Again, for the front end, how are you going to build out that front end? Are you going to create a simple web form? Again, basic HTML with just HTML, not even CSS, just HTML. You can create HTML forms and be able to print out HTML reports using a backend language like PHP. So PHP can pull data from an HTML form. It can send it to a database. If you need a report done, it can go to the database, pull the information you're asking for, and you can print it out just in HTML. Or you could add some CSS, or you could add some JavaScript, or you can make a native app for iOS or Android, or again, and how you develop that. Are you going to develop that in Java? Are you going to develop that in HTML and CSS? Are you going to develop it, with Swift or whatever else? Again, the big thing to understand is, I don't know, do whatever the hell you want to do. And so again, that's one of the big problems that people run into when they start dealing with databases, is they think that the database is a complete product somehow. Like, I've installed MySQL, I've installed MongoDB, now I have something. I know, now you just have a place to dump information. To actually make that useful, you need a whole bunch more. Because again, don't get me wrong, you can go to the command line. So if you're dealing with a MySQL or a SQL server, you can go to the command line. You can use what's called SQL, structured query language. So you can use structured query language to pull information out of the database. You can put information into the database. You can create tables. You can do all of that kind of thing. But seriously, it's the equivalent of trying to surf the web using the command line. Can you do it? Yes. If you're an administrator, might there be a reason that you need to do it? Yes. That's not how your end users are going to interact with it, though. And so again, I think that's one of the big problems people run into. They get a little bit confused is basically how all of this really works at the end of the day. So as always, I enjoyed doing this video and I look forward to seeing you at the next one.